So we are told that a pollster wishes to estimate the true proportion of US voters who oppose capital punishment. So the question here is how many voters would be surveyed? How many voters? So we are looking for the sample size. And then we are also given the how many voters will be surveyed in order to be 95% confident that a true proportion is estimated to be within 5%. So looking at this information here, we can see that our margin of error is 0.05. But before we proceed, let us look at the formula we are supposed to use. So when we go to chapter 16, we have this formula here. This N here gives us the formula to determine the sample size we need. So you see, this is the formula here. So let's try to write out that formula. So we have N to be P hat, Q hat, margin of error divided by Z all squared. So you see, this is the formula we are going to use if you want the sample size using proportions. So we have this formula here. Now, Z is the critical value. Is the critical value. So how do we determine the critical value? Let's get to StatCrunch and do that. So to get the Z, the critical value, I go to StatCrunch, I go to stats, I go to proportion stats, one sample with summary. The first thing you have to input here is to make sure that here we are told that in order to be 95% confident. So you can see from here, 95% confidence. It's right here. So that is the Z we are going to use to read. So you see, I make this 95 here. And then I click on show critical value. That is what I want. So you have to click on show critical value. Now here you can put any number here. So let me put success to be 4. Let me put number of observations to be 10. You can put any number because I don't care about the confidence interval. I only want the critical value. Is that okay? So then I hit compute and then there's the critical Z. That is what I just want. Is that okay? Now look at something here. Let's say that Emma decides to put here 10 and put here 100. What she has to do is that she has to make sure that here is 95%. It corresponds to this. Is that okay? And then click on show critical value. Same thing. You see, it doesn't matter what you put in that, but the critical value is the same. Is that okay? So this is the critical value. So I'm going to write that Z value down. Z is 1.959. Now let's proceed. So you see, the margin of error is 0.05. You can see it's within 5%. 5% is the same as 0.05. We just got our Z. Now, what is our P hat and Q hat? We don't know from this problem. Is that okay? So anytime we do not know what P hat and Q hat is, let's assume P hat to be 0.5. So anytime you are looking for the sample size for proportions and then you don't know what your P hat and then Q hat is, always assume P hat to be 0.5. Is that okay? So now, this is very important. So now we have N to be 0.5. Q hat is the same as 1 minus P hat. 1 minus 0.5. All divided by margin of error, 0.05. Divided by Z, 1.959 all squared. Now let's use our calculator. 0.5 times 0.5, the numerator gives me 0.25. And then now I need 0.05 divided by 1.959 all squared. I get 0.0000651 right here. And then you just use your calculator to do this. So when I do that, I get about 384.1 something. And so you can see that because you are looking for the sample size, it cannot be a decimal. So it's approximately 385. And you can even see the rest of the answers are not even close. Is that okay? So this is how to determine the sample size for the proportion. So this is the formula we have. And then looking at this problem, anytime we don't have the proportion, the sample proportion, let's assume P to be 0.5 because that is the value, even if it's underestimated, this is going to give us the sufficient sample size we need. Is that okay? So let's use this. Let's get to 20. 20 says that, so we are going to use StatCrunch to do 20. So let's get to StatCrunch. What is 20 saying? 20 is saying that we should use a T-table software or calculator. All we know in this course is we are going to use StatCrunch to do that. Now we are going to, they ask us to estimate the critical value. The critical value. So we are going to look for the critical value of T. We are looking for the critical value of T. And then what information do we have? We have the confidence level and then the degree of freedom. So since we have the degree of freedom to be 15, it means that the sample size is 16 because the degree of freedom is what? The sample size minus 1 for one sample. So we can see that the sample size is 16. But how are we going to get the critical value T? So to do that, we go to StatCrunch, stats, T stats, one sample with summary. Stat, T stats, one sample with summary. And then I click on that. What information do we need to input? Now looking at this problem here, we have a degree of freedom to be 15. It means that the sample size is 16. So let's input the sample size correctly. Is that okay? The next thing we want to input is the confidence level. So we are told that what 95% confidence level. I make sure that here is what? 95. Is that okay? The next thing I do is I click on this. I show that is what I'm looking for. The question is saying look for the critical value. So you have to what? Highlight that, or you have to select that. Is that okay? So since we have that, the rest you can put in, let's put in a mean of 3, standard deviation of 1. This 2 doesn't matter. But if you put in a wrong sample size, you'd get the problem wrong. Is that okay? Make sure, look at how I did it. I inputted the right sample size. I inputted the right confidence level. Is that okay? And then we click on compute. So this is the critical T. The critical T. Critical T. You can see from here the degree of freedom is 15, which is correct. Is that okay? So the critical T is 2.13, and then we can see that from here, 2.13. Let's get to 21. 21, we are asked to use the T table or the software or a calculator to estimate the indicated P value. How are we going to do that? We are still going to use StatCrunch. Here, unlike where we used to know if we have the information, the summary information, whether the sample means, standard deviation, and stuff, then we could see the p-value. Here, it is different. Here, we have rather been given the test statistic, and then we also have the degree of freedom, and then we want the p-value. How do we do that? Before we proceed, you have to be able to identify that this is a two-tailed test. How did I know it's a two-tailed test? Because the T has an absolute value by it. Is that okay? Since the T has an absolute value by it, I see that is a two-tailed test. You can see this T here doesn't have an absolute value by it. That is a one-tailed test. Is that okay? So since the T has an absolute value symbol by that, it means that it is a two-tailed test. Is that okay? So you take note of that, two-tailed test. Now we are going to learn how to use StatCrunch to get the P value. So to do that, we go to StatCrunch, Stats, Calculators, and then we scroll down to T. To use StatCrunch to get the p-value for the T test statistic, we go to Calculators, and Stats, Calculators, and then T. I click on this one here. Is that okay? Let's input our degree of freedom. Now, when we look at this, the degree of freedom is what? 24. Degree of freedom, 24 degrees of freedom. So degrees of freedom, I put in 24. Is that okay? Now, when I look at this is greater than 1.76. I change this to be greater than, I put in 1.76 here. Is that okay? Then I click on compute. When you click on compute, this is the value we get. Is that okay? But remember, this test statistic is a two-tailed. So since it's a two-tailed, whatever you get here, multiply that by 2. Is that okay? So here, I got 0.0455. 0.0455 times 2. That gives me 0.091. Is that okay? because it's a two-tailed, after doing everything, we multiply the value we have here by 2. Is that okay? So you can see when I multiply by 2, I get 0.091. Okay, now let's do same thing, but from a different so you can see from here, this is what? One-tailed. Same thing, we are looking for the what? The p-value, and it's also the t. So start crunch, we are still at the right place. Is that okay? Does that make sense? We are still at the right place. So to get the p-value, here we have the sample size to be 31. If the sample size is 31, what is the degree of freedom? 30. Is that okay? So degree of freedom is the sample size minus 1. So the degree of freedom is 30. So I put in here 30. And then when I get here, it's greater than or equal to 2.13. I change this thing here to be 2.13. Remember, this is what? One-tailed, because the t doesn't have an absolute value by that. If it's one-tailed, we read directly. So we click on this, the answer is what? 0.0207. We don't need to multiply anything here by 2. Is that okay? It's one-tailed, so this is fine. And so you can see is 0.0207. Is that very clear? Okay. Let's get to 23. So 23, we are told that what? 30 randomly selected students took the calculus final. What information do we have? We have the sample mean and the sample standard deviation. That gives us the idea that we are going to use the t, and it wants us to construct the 99% confidence interval for the mean score. So to be able to do this, we will need to use StatCrunch. So let's get to StatCrunch. We go to Stat, T starts one sample, and then we go to with summary. I click on that. Let's input our information. Here we are told that what? 30 random students. So we put sample size here to be 30. What does the sample mean? The sample mean is 88. I put 88 here. What is the sample standard deviation? The sample standard deviation is 9.6. I am not interested in hypothesis, so I click on the confidence interval because that is what I am asked to find. I am asked to construct a 99% confidence interval. So you see, I click on that. Now, be very careful. You have to change this to match this, Is that okay? So it means that here has to be what? 0.99, because we are looking for the what? 99% confidence interval. And then I'm not interested in the critical value, so I won't click that. Is that okay? I save time. I click on compute. What is the lower limit? 83.17, 92.83. Is that okay? Good. Let's get to 24. So 24, we are told that what? A random sample of 30 households was selected from a particular neighborhood. and then the number of cars for each household is shown below. We should estimate the mean number of cars per household for the population of the household in this neighborhood. And then we should give the 95. So when I look at this possible answers here, it is a 95% confidence interval that is here. Is that okay? So how do we do that? We need to input this data here in StatCrunch. So let's get to StatCrunch and then input the data. It doesn't matter how you input them. You have to input the data correctly. So I am doing mine. I do it column by column. 2, 1, 1, 0, 3, 0. 1, 2, 4, 2, 0, 1, 3, 1, 0, 2, 1, 2, 1, 2, 2. 0, 3, 1, 1, 0, 4, 2, 2. So I've been able to input my data here. And then I want the 95% confidence interval. So to do that, we go to start, T-start, but one sample, but this time around with data because we have the data. Is that okay? I click on with data. You select the column where you inputted the data. So here, I didn't spend time to name it, so it's still val1. Is that okay? And then the confidence interval is 95. So I change this to 95. Is that okay? I hit compute. And this is 1.07, which is the same as 1.1, 1.9. 1.1, 1.9. Is that okay? Let's get to 25. 25 says that we should interpret the confidence interval. And so you have to be able to read the problem first. So the problem says that a random sample of clients at a weight loss center were given dietary supplement to see if it would promote weight loss. Then the center reported that 100 clients lost an average of 41 pounds. I think this didn't show properly. And the 95 margin of, they give the margin of error too. But to save time, one thing I can see from here is that I'm not going to use StatCrunch. Why? Because I can see the interval is what, 32 and 50, 32 and 50, 32 and 50, 32 and 50, 32 and 50. Is that okay? StatCrunch only gives you the numbers. So here I'm not going to use StatCrunch because I could see the interval is the same. Now we just have to provide the right interpretations for the confidence interval. And so the right interpretations that we've learned and you've been doing in your homework is that we are 95% confident that what the true mean weight loss produced is between this and then that. It is not 95% of the people. The confidence interval interpretation, it shows the level of confidence that the mean weight or the mean or the true mean or the true proportion is between a certain interval. So that is what we have to do. So you have to be careful. It is not the average or the sample average or the sample mean. It's always the population. So you just have to take note of that. Let's get to 26. 26 says that we should write the null and the alternative hypothesis. We want to see if the mean number of minutes cell phone users use each month has changed from its mean of 120 minutes 2 years ago. You want to see if this has changed from 120 minutes. So what did you do? You randomly sample 100 cell phone users and find an average of this. So this is the sample mean of the 100 cell phone users you took. And then this is the X bar. So this is the X bar. We want to write the hypothesis. We learned that the hypothesis is about the population. So we can see, we want to see if the minutes has changed. So it should be equal to and not equal to. Is that okay? Because it says has changed. If it says has increased, then it should be greater than. Is that okay? So that is what you need. So we know it's equal to and not equal to. Based on that information, we can see C, D, and E are out. Is that okay? Now the contention is between A and B. B is out because B here is 135. 135 is the sample mean. Is that okay? That is why it is not B and it is what? A. Is that okay? So it is like, for example, if I had wanted to do this, if you go to StatCrunch, you go to tstat one sample with summary, would have inputted the 135 here and put the 120 here. Is that okay? Do you get what I mean? Would have inputted the sample mean of 135 here. And then here would have been the what? 120. Is that okay? Good. Now let's proceed to 27. So 27, it says that use a hypothesis test to test the given claim. So now the question is that, is the mean lifetime of a particular type of car engine greater than 220,000 miles? So here it's easier to see that the alternative hypothesis is very clear. Is that okay? So mu greater than 220,000. Now to test this claim, a sample of what? 23 engines is measured. And then this is the sample, and then an average of what? 226,450 miles. So this is the sample mean. You're also given the sample standard deviation. Now here I could see that the p-values are different, which means that I need to use StatCrunch, and then we're also going to make a decision. So let's use StatCrunch to do this. So we go to StatCrunch, stats, tstats, one sample with summary. What does a sample mean? The sample mean is, you are told here, yielding an average. So that is a sample mean. So that is 2, 2, 6, 4, 5, 0. You are given a sample standard deviation to be 11,500. The sample size is 23. These informations are very clear. And then the hypothesis based on this information here is the mean lifetime. So greater than, so we can see here should be greater than. Is that okay? And then here is going to be 220,000. If you put in if you get the hypothesis wrong, it's going to impact your p-value. Is that okay? So we can see from here, we can then click on, you can even change the significance level to be 0.01. Let's get the p-value. I think I can change it. Let's get the p-value. So we click on this guy here, and then this is our p-value, 0.0067. So 0.0067. We can see the p-value looks like this. Is that okay? Now, in your exam here, it's easier because you can see the p-values here are different. But in your exam, the p-values can be the same for multiple choices, which means that it's important for you to interpret. Is that okay? So we are going to compare the p-value to 0.01 because here the significance level has been given. Is that okay? So I want to ask you, is this p-value small or larger as compared to 0.01? Is it small or high or big? It's small. This is 0.006. This is 0.01. So this is bigger than this. Is that okay? And then now, since the p-value is small, we know that if p-value is less than this, we reject the null hypothesis. That is our decision. We reject the null hypothesis, and then we conclude that there is what? Sufficient evidence. Anytime you reject the null hypothesis, there is what? Sufficient evidence. Is that okay? Good. So there is sufficient evidence that the engine lasts longer than 220,000 miles. Now let's get to 28. For 28, we want to interpret the meaning of a type 1 error or a type 2 error. Now we want to explain a type 1 error. So first and foremost, before we begin, what is a type 1 error? Let's see. So this is a type 1 error. A type 1 error is what? Rejecting the null hypothesis when in reality the null hypothesis is true. Is that okay? So you've made an error by rejecting it, but in reality, it is what? True. So you have made your conclusion saying that, oh, we reject the null hypothesis, the p-value is small and blah, blah, blah. But in reality, you've made a mistake. And the mistake is that what? The null hypothesis is true, but you said we should what? Reject the null hypothesis. How do we? And then I went ahead to provide you an explanation here. Type 1 error is also occurs if a jury convicts an innocent person. And then I also went ahead last week, we talked about this too as well. We talked about 1 minus alpha and also beta. I've uploaded those videos on As You Learn, so you can look at that. So here, type 1 error. This is true, but we did this. So we can see that what? Let's look at A. The advocacy group will conclude that the mean amount of juice is less than this when in fact it should be equal to this, not less than that. Is that okay? When in fact the null hypothesis is what? Mu equals what? 16.1. So here it says that what? The advocacy group concluded the mean amount of juice is less than this when in fact it is what? This. So this is how to interpret type 1 error. Now let's get to 29. 29 says that a researcher collected data on the annual salary of doctors in Illinois. He wishes to construct a confidence interval for the mean annual salary. Which of the following are true? So, based on this, let's try to look at the slides we have here. So it is based on the confidence interval. So here we can see from here that if the level of confidence increases, the confidence interval gets wider. If the level of confidence increases, the confidence interval gets wider. So here, I says the 98% confidence interval would have a greater chance of including the true mean than a 95% confidence interval, which is true because that interval will be wider than this one. Is that okay? So the wider the confidence interval, the higher the chance of it including the true mean. Is that okay? Let's get to II. A 98% confidence interval will be narrower than this. No. A 98% confidence interval will be wider, not narrower. Is that okay? Based on this information we learned here. So that tells us that the question is which of the following are true? II is not true. The third one, 98% confidence interval requires the researcher to take a larger sample. No, it doesn't matter the sample. So we can see that it is only I that is what? True. Is that okay? Good. Now, let's get to 30. So for 30, we want to construct the confidence interval for the difference between two proportions. We talked about, this was the last chapter we talked about. And so here we are told that what? We are going to look at the GPAs of students at two different colleges. And then we are told that they are independent. And then so let's try to input this information here in StatCrunch. So here I want to label them to be college A. And then here is college B. Now let me input the data from college A. Let me do that for college B. So I've inputted the data for college A and then college B. We want to determine the 95% confidence interval. So to do that, we go to stats, T stats, to sample with data. Start, T stats, to sample with data. So I click on that. Sample 1 is college A, sample 2 is college B. And I want the 95% confidence interval. And then let's hit that. So you see negative 0.78, and then 0.129. Is that okay? So that is how to do 30.